Hello. So today we're going to talk about parametric equations and plane curves. This is supposed to be an and symbol here. Parametric equations are a situation when we have two functions that are also like parametered. I don't know what verb I really want to use here, but there's a parameter involved. Usually it's t. Okay, so we have a third variable t. So if we have a parametrically defined function, then we're going to have x and y coordinates that we're still going to use as normal, and then we'll have that third variable t. So x would be a function of t and y would be a function of t, right? And then these are called parametric equations. And if we have these in a curve, well, the points on the curve are going to be defined by f of t, g of t, so x and y, right? So let's actually see this in action. You probably remember some of this from pre-calculus, but we'll review it here. So a curve C is defined by the parametric equations x equals t squared and y equals t cubed minus 3t. We're asked to plot points to sketch the curve described by the parametric equations and then mark the orientation on the curve. Well, I'm going to do my x's first here. So when t is negative 2, x is going to be 4. When t is negative 3, x is 3, negative 1 is 1, 0 is 0. 1 is 1, radical 3 is 3, and 2 is 4. Okay? So now I'm going to do my y values. We're going to have negative 2, so that's going to be negative 8 minus plus 6 would be a negative 2. This is going to be 0. This is going to be 2, 0, negative 2, 0, and 2. And actually, I wish I had written these in two different colors. Maybe I'll kind of do that now. So I'll do the x values, excuse me, in pink. So here, this is our x-axis, this is our y-axis, okay? So when t is negative 2, let me stop 1 second here. Okay, so now I can actually graph these, right? So when t is negative 2, this is going to be at the point 4, negative 2, right? So this is 4, this is negative 2 right there. And then at negative radical 3, we're going to have 3, 0, so that's going to be right here. Then when t is negative 1, our time, we're going to have 1, 2, all the way up here. And when it's 0, we're at 0. And the thing about parametrics is that this is moving, all right? So time is moving. There's a direction to this. So time is moving in this direction, okay? So I've graphed all these. Now let's graph these. So I've got 1, negative 2. I've got 3, 0. And then I've got 4, 2, which is about right here. So this continues. As time moves, this loop continues on, and I can, again, draw these little arrows to kind of display what that looks like, all right? So you can see this graph isn't just showing us, you know, like a 2D, it's not just showing this a function, it's showing this function as it relates to time, because we're also seeing, you know, not just the direction, but like when and at what time it's moving, okay? I don't know if I explained that very well, but let's do another example. Maybe it'll make more sense. So, change the following to rectangular form by eliminating the parameter, then graphing. Okay, that sounds a lot more complicated than it really is. So if we have x equals 1 over radical t and y equals t over t plus 1, well, I'm going to rewrite this so that I can kind of get x in terms of t and then y and then do some substitution here, right? So I'm going to have I'll have radical t plus 1 going to be equal to 1 over x, right? So t plus 1 is equal to 1 over x squared. So t is going to equal 1 over x squared minus 1, and ultimately t would equal 1 minus x squared over x squared. Cool. Now I can take this t and substitute it in for y. So y is going to equal 1 minus x squared over x squared over 1 minus x squared over x squared plus 1. And if I multiply by x squared over x squared, I get 1 minus x squared over 1 minus x squared plus x squared, right? Because I multiplied by that one there, which just becomes 1 minus x squared. So y is equal to 1 minus x squared. Then I can graph it, I guess, if I really want to. I kind of don't want to badly at the moment. But our graph is going to be, you know, let's see here. When x is 0, y is 1. When x is negative 1, y is 0. This is what I should be doing, right? So I should be going from negative 1, 0, 1, 2, 3, 4, right? So that I know my direction there. So negative 1 was 0, 0 was 1, 1 is going to be 0, 2 is going to be negative 3, and that's probably enough, right? So my graph, I wish I'd put it there. My graph will look like this, okay? This is my t, this is my y, all right? Let's do another example. Use trigonometry to eliminate the parameter and sketch the curve. So we're given y equals 4 cosine of theta, or I'm sorry, x equals 4 cosine of theta, y equals 3 sine of theta, and theta is between 0 and 2 pi, okay? So we have x equals 4 cosine of 3 sine theta. I think the easiest way to do this is to kind of use some of our trig identities, but I'm going to rewrite this. So I'm going to rewrite x over 4 is equal to cosine theta, and y over 3 is equal to sine theta. All right? Then I'm going to actually square all of this. Square that, square that, square that, square that. So this is not good notation, but it ends up as x squared over 16, y squared over 9 is equal to cosine squared theta is equal to sine squared theta. Right? Then I'm going to add these together, one giant addition sign. This is going to equal 1, right? So I'm going to end up having x squared over 16 plus y squared over 9 is equal to 1. Isn't that kind of fun, right? And if I graph this, you end up having an ellipse. Do you remember ellipses? An ellipse where hk is our base, and in this case, that's at 0, 0. So our radius of our x goes to 4. And of our y, it's at 3, and I can draw that. Man, that's a really ugly looking ellipse, but an ellipse nonetheless, okay? So we can actually find parametric equations doing some different calculations. So we're asked to represent the equation y equals 2 minus x squared by using the parameters x equals t. Well, if we're using the parameter x equals t, we're just going to rewrite this as when x equals t, y is going to equal 2 minus t squared, right? That's just substitution, right? And what if we're going to use m is equal to dy over dx? Well, we can actually find our m here. So m is also going to be equal to a negative 2x, right? And I can rewrite this in terms of x. So x would be equal to m over negative 2, right? So y, I'm going to go back to my original equation here. Y is going to equal 2 minus x squared, which is just, 2 minus m over negative 2 squared, which is going to be 2 minus m squared over 4, which equals negative, actually that's it. So y equals 2 minus m squared over 4, and x equals negative m over 2. Okay, so I've rewritten my parameters there. All right, so let's talk about parameterization of a line. Given a point and a slope, if we're given a point and a slope, the line through a point with slope m is parametricized by x equals a plus rt, y equals b plus st, for any r and s where m is going to equal to s over r. If we're given 2 points, we have a line through P equals AB and Q equals CD. X is going to be equal to A plus T times C minus A. Y is going to be equal to B plus T times D minus B. And that segment corresponds 0 is less than or equal to 1 is less than or equal to T. All right, let's actually do an example here because I think that will make a lot more sense. So we're asked to find parametric equations for the line through P equals 3, negative 2 with a slope of m. Okay, so you might remember from the previous page that x is going to be equal to a plus rt, and y is going to be equal to b plus st. Okay, so our a, like p is equal to a comma b, right? So a is equal to 3, and b is equal to negative 2. And m was equal to s over r, which is equal to actually 4, right? Which is equal to 4 over 1, okay? So now we know s is 4, r is 1. We know all of these variables. So we can rewrite this. So x is going to be equal to 3 plus r is 1 t. And y is going to be equal to b, which is negative 2, plus 4t. And that's it. That's how easy that is, right? To find those parametric equations and rewrite them. Right. Let's do another one, but this time through 2 points. We're given p equals 2, negative 6, and q equals 4, negative 3. Well, again, our formula is from the previous page. X equals a plus t times c minus a. I switched pens because I thought this would be better, but I think it might be worse. And y is equal to b plus t times d minus b. Okay. So our p is in the form ab, and our q is in the form cd. Right? So a here is going to equal to 2, b is going to be equal to negative 6, c is going to be equal to 4, and d is going to be equal to negative 3. So far, so good? So our x value is going to be equal to 2 plus t times 4 minus 2, which I can simplify to be 2 plus 2t. And our y value is going to be equal to negative 6 plus t times negative 3 minus a negative 6, which becomes negative 6 plus 3t. Okay, that's it. I kind of love doing these. They're just fun, simple. It's like going back to your Algebra 1 days, right? Okay, that's it. Gosh, that was a quick lesson. So hopefully all of that made sense. If you have questions, leave them in the comments, and I will see you in class. Bye.